denominator is 8, so we need a 4, 11 pi over 8. Okay, so it was 7 pi over 8 plus pi over 2. Just making sure. 7 pi over 8 plus pi over 2. Yes, with 1 and with 2. I'm getting exact the same thing. So 7 pi over 8 plus k equals 1 pi over 2. 4 plus 7, 11. Okay, so we don't have to repeat that because it's already there. So let's see what happens with k equals 2. So theta equals 7 pi over 8 plus pi. So theta will be 15 pi over 8. Okay, we're getting that again. So let's try. I think it's good enough, but let's double check. The next one will go over 2 pi. So k equals 3. Theta equals 7 pi over 8 plus 3 pi over 2. So the least common denominator is 8. So 12 plus 7 is 19. 19 pi over 8 is more than 2 pi. This was an interesting one. And that was the reason because the period is so small. The period for this function is pi over 2. That's why we had many more solutions. And that was because these angles are so small. Very good question. Thank you, Blake, for bringing that to class. Good. Other questions? Anything else you need help with? Anything else?
I have a question.
Yes, I'm ready.
There's no graphing in the in this exam, right?
The only reason you can, if you like, for extra credit, you can graph it if you want. All I really wanted you to tell me is where would you graph it? So if you just give me the amplitude, the phase shift, the period, then I'm assuming that you're not going to have any difficulties in finding, let's say, the phase shift, I don't know, 0 to 2 pi in our sine function, simple basic function. What can you do with this? You can just copy the graph, right, from the graphing calculator. Because I just think that it's not an easy task to graph these functions by finding points. I normally, myself, I don't find points. I just use the references, right? So you saw me how I graphed, right? And I said, okay, the amplitude, let's say, is 1 and negative. So the amplitude is 1. So this is 1 and negative 1. So this was pi over 2 and then pi and 3 pi over 2 and 2 pi. So I did not find any really real points other than the generic ones. So I did not calculate, let's say, sine of pi over 3 and show you that this is indeed the square root of 3 over 2. I did not do that because it's not an easy task.
Yeah. Okay. So I was just
Yeah. So I did not show that.
All right. Thank you.
I used the viewing window in the graphing calculator. And if you just tell me, you know, for this particular function, of course, it's the basic sine function. I said 0 to 2 pi. And they, you know, because it's between negative 1 and 1, I said, okay, just show between negative 2 and 2. So you have a nice viewing window.
Okay.
Because otherwise I have to show how I determine this point and how I determine this point. This is easy, but it requires different points. But once you know the shape, I'm happy if you know the shape. If this is the shape for sine, and this is the vase, the shape for cosine. And if you remember the how tangent and cotangent look like, I'm more than happy. but no, I did not ask you to graph.
All right, thank you.
Was that the question, Kevin?
Yes.
Okay.
Yes. Thank you.
Good. Other questions? Anything else that you encountered? Anything? So did you enter the, Blake, did you enter the answers for theta?
Yeah, I got them.
Did they accept it?
Yeah, these were the answers. Yeah. Well, this was actually on a written homework that we had to turn into you.
Okay.
I was saying Pearson because there were similar questions to this
Okay.
that I had to do on Pearson, not this exact one.
Okay.
Um,
No,
Yeah.
I did not put anything in such detail and so much work on this test. They're very simple examples that we did in class, but this was a perfect example to see. Good. Anything else that you would like to go back to, or I will choose? Other questions? Anything else you need help with? From all this list, is there something that you would like to go back to? Any question?
Can you go back to number 4?
Number 4, the value of the expression.
Yes, please.
Very good. Okay, so let's take a look. We can make one up, or you can give me one.
You can make one up. I don't have examples right now.
Okay, so let's say sine 45 times cosine 45 degrees minus tangent squared 45 degrees, as an example. Anyone would like to help with this one? Sine 45.
Square root of 2/2.
Good. Cosine 45.
Also square root
Of
2/2.
course. Tangent 45. Exactly, it's this over this, correct. So the square root of 2 times the square root of 2 will be 2. So this product is 1/2. 1/2 minus 1 is negative 1/2.
Wait, so I just ignore the squared for the tangent?
Let's
Or-
let's square 1.
Oh, never mind.
That's okay. Good. Anything else you'd like to pick?
Could you show that last problem again?
Yes.
Thank you.
Thank you. Other questions? Anything else you'd like to pick? Do not rush. You see what happens when we rush? You have plenty of time to finish the test. So I wanted to go back to the book. Where is my book? I hope I'm already signed out from everything, I guess, by now. Okay. So would you like to look at another trig equation? What about 66? 60, is that okay? Did you want to choose something else?
Wait, can you pull up the list again? Of the topics on the exam? Actually, can you go over number 3? Like the other method of doing it? For factoring, I guess.
So for 2y² minus 9y plus 4 equals 0, as we discussed, it was a long time ago.
Yeah.
So we have the product has to be 2 times 4, which is 8, and the sum is -9. So we need two numbers whose sum is -9 and whose product is 8. Both numbers have to be negative.
-8 and -1.
-1 and -8. The product is 8, yes. The sum is -9, yes. So then we go back and we replace -9y. So 2y² minus y minus 8y plus 4 equals 0. So this is still the same thing. But we determine these two numbers and we want to factor by grouping now. So y and 2y minus 1. And as I always like to do, to remind the students that this has to be the case. If it's not the case, then I cannot continue. But I know it has to be because I found two numbers whose product is this and whose sum is this. So this has to happen. And only now I look and I factor out a -4. Because -4 times 2y is this, and -4 times -1 is this. And then I factor out 2y minus 1 because that's the common factor, and I get y minus 4 equals 0. And then we have two options, 1/2 and 4. The other option is the Corati formula. So when you determine y is negative b plus or minus b² minus 4ac, so which is 4 times 8 divided by 4. Solutions have to be the same, 9 plus or minus the square root of 81 minus 32 divided by 4. So y equals 9 plus or minus 81 minus 32 is 49, so the square root of 49 is 7 divided by 4. So then we have two options. 9 plus 7 is 16 divided by 4 is 4. 9 minus 7 is 2 divided by 4, and we get 1/2. And the third option is with the apps in the graphing calculator. Is that what you meant?
Yeah, but then also I remember doing the Pearson.
Yes.
And the method with the Pearson, it just took the equation while it still had cosine and the trig identities in them, and then did factor by grouping that way, and then that was really how that went. It was basically the same thing, I guess, but I guess this is easier.
The reason I used a substitution is because this is quadratic in form. So now your y is the cosine. So that's all you need, just to write the cosine x equals 1/2 and cosine x equals 4, and you take it from here. You don't have to use a substitution if you don't want to. But then from here, you still have to solve for x.
Okay, thank you.
Thank you. Anything else? Anything else? Okay, I don't know if you still want to do 66 or any other problem from here, or something else. Anyone?
We finished 66.
Okay, so in 66 we have cosine square theta minus sine square theta and plus sine x. I'm sorry, sine theta I meant to say. Good. So I just picked that. If you want to pick another way, we can. So see what happens here. I have sine and I have sine. I don't want cosine in the problem. Well, I cannot erase it, but I can replace it by what it equals to. Because we know that cosine squared is 1 minus sine squared. Minus sine squared plus sine x, plus sine theta equals 0. So now from here, we're going to combine like terms and rearrange everything. So I have -2 sine square theta plus sine theta plus 1 equals 0. As I mentioned, only if my life depended on it, I would, somebody's forcing me somehow, I will never solve a quadratic equation with a negative leading coefficient. So I'll multiply both sides by -1. 2 sine squared minus sine theta minus 1 equals 0. And I will factor or use apps or use the quadratic formula. Can anyone factor this for us? With substitution if you want, or without substitution, whatever works for you. Can anyone give us the factored form? Anyone, please. Okay, 2 sine theta plus 1, sine theta minus 1. Let's check. 2 sine squared minus 2 sine theta plus sine theta, 1 times -1. So there are two options. Sine theta to be -1/2 and sine theta to be 1. This is easy. Theta equals pi over 2 plus 2 pi k. This requires a little bit more work because we have to look at two quadrants. Obviously with a reference angle of 30 degrees or pi over 6. This is pi over 6. And this is pi over 6. So the first angle is this. And the second angle is this. Of course, with pi over 6 as the reference angle in both cases, because it's 1/2. So one answer is pi plus pi over 6. The other answer is 2 pi minus pi over 6. So pi plus pi over 6 is 7 pi over 6. And 2 pi minus pi over 6 is 11 pi over 6. In both cases, plus 2 pi k. If we are asked for all solutions. If we are asked for all solutions, we have to write plus 2 pi k. Any questions on this? Anyone, please?
If it was with tangent or cotangent, it will only be pi, right? Pi
Yes,
k?
yes.
Okay.
So only for tangent and cotangent, the period is pi. Everything else has 2 pi. In other words, what does this mean? It means that tangent repeats in blocks of pi, but everything else repeats in blocks of 2 pi. Or chunks or pieces, if you want. Anything else? I hope you're going to find this test to be the easiest of all. we still have a lot of work. I know we're close. I'm gonna stop in a second.